Hi everybody, Ms. Suchi here. We are going to be doing geometry notes on lesson 1.4. This is covering polygons. And if you remember from one of our other videos, a polygon, remember, has straight sides. So it's going to be all the different type of shapes that you're pretty familiar with, even from preschool age. So our objectives today are listed at the top: being able to define and classify polygons based on the number of sides, or special properties of the polygons, distinguishing between concave and convex polygons, and determining if polygons are congruent based on their markings and measurements. So first thing we want to do is we want to give an official definition for a polygon. And again, that was listed in one of those other videos, but we will recap here. So a polygon is a closed figure and it's flat. It's 2D, so it's in a plane. And we'll talk about 3D figures later on this year, but polygons are the flat 2D ones. They are formed by connecting line segments, which remember has a start and a stop. They're connected endpoint to endpoint, and they can only connect two endpoints together at once. So if I have one side here of a polygon, I'm going to connect it to another side, and you can see here that there's only two segments coming into that endpoint. We can't have more than that. That would not make a polygon. All right, when we are classifying these polygons, we're going to be classifying them by the number of sides that they have. And a lot of these are probably really familiar for you. So a three-sided polygon is a triangle. The four-sided polygon actually confuses a lot of people. They think square or rectangle right away. But there's lots of different four-sided polygons: kites, trapezoids, rhombus, parallelogram. And so anything with four sides is called a quadrilateral. All right, five sides is called a pentagon. Six sides is a hexagon. And seven sides is another one that a lot of people get mixed up on. This is a heptagon. All right, now I bet eight sides is one that you are familiar with because octopuses have 8 legs. So this is an octagon. 9 is a nonagon. 10, like 10 years, is a decade. So this is a decagon. 11 is an undecagon. And 12 is a dodecagon. Okay, now there are names for polygons with more than 12 sides. So 13 sides, sided polygon has a specific name. But as you get to more sides, the names become more complex. And so beyond the 12 sides, it's not really that important to know the specific names. So let's say n here is standing for any number bigger than 12. We would just say n, whatever that number is, dash gon. So let's put an example on here. Let's say we had 15 sides. I would call this a 15gon. So any number bigger than 12, we can just put the number in front of the word, or the n there of gon. All right, so now those are the classifications of the polygons. But if I want to distinguish a specific polygon, I want to name it. And when you name it, you first have to state what type of polygon it is. So this one has 1, 2, 3, 4, 5 sides. So that's why they have pentagon listed first. And then you get to follow by the letters that are representing the points on the corners, or the vertices of the polygon. Now, it doesn't matter where you start, but it does matter that you go in order. So again, you either go clockwise or counterclockwise You just have to pick where you want to start. So in this case, they started with A, and they went counterclockwise around the figure, putting in A, B, C, D, E. But you can name these more than one way. So I could also call this pentagon. And then maybe I'm going to start at D and go clockwise. So I could call it D, C, B, A, E. So as long as you are going in order, not skipping across the shape, that works. All right, now I did mention this. The vertices is the plural word for vertex, and those are the corners. So it says each line segment of a polygon is called a vertex. Oh, I'm sorry, each line segment is called a side, and each endpoint where the sides meet is called a vertex. So the sides, like if I were to draw a pentagon here again, each of these are the sides, and the vertices, or each vertex, is at the corner. All right, our next word is consecutive. We had adjacent angles as one of our vocab words from a while back. Adjacent kind of meant like next to or touching. Consecutive kind of means the same thing. So consecutive is also another way to say next to. So if I have consecutive numbers, those are numbers next to each other, 1, 2, 3, 4. When we're talking about consecutive vertices, they are vertices that are next to each other, that are connected by a segment between them. So consecutive vertices are, I don't know what vertices that are connected to each other. Connect to each other. All right, so like let's say, draw another pentagon here. And I'll call these corners A, B, C, D, E. So a pair of consecutive vertices in this case would be A and B, because they are being connected by this segment here. All right, a diagonal is a segment. So that means it's got a start and a stop. That connects two non-consecutive vertices. So if consecutive means next to each other, non-consecutive means they're not next to each other. So if I were to draw that pentagon again, A, B, C, D, E, I couldn't count A and B as a diagonal. The diagonal has to connect A to something that it's not already connected to. So I could stretch it across to C. And then AC is an example of a diagonal. All right, our next word, convex. I think these are related to if you have prescription glasses too. But convex polygons are kind of like the normal polygons that you would see. Square, rectangle, pentagon, octagon. In this case, when I draw in the diagonals, they will all end up on the inside. So if I go back up to this one here, and I were to draw in the rest of the diagonals, notice all of the diagonals end up on the inside of this figure. So for convex polygons, it's where all the diagonals are inside the polygon. So you could do like a square, pentagon like before, hexagon. And if you were to draw in these diagonals, you would see that they all end up on the inside. So it has quite a few diagonals. Try not to miss that in here. think I got them all. All right, so these are all on the inside for convex polygons. Now, I can still have a four-sided figure, a quadrilateral, that is not convex, but is concave. So four sides that are concave, like that. So it still has four sides. It's still a polygon because it's connected by segments, each connecting to only one other segment itself. And so a concave polygon is kind of like one that's caved in. And when I draw in the diagonals, I'll have one here, and I'll have one here. There's going to be at least one diagonal is on the outside of the polygon. Now, you could have more than one on the outside, but it has to have at least one on the outside. All right, this word again, we've seen that word lots of times. We've seen it with this symbol, and we've seen it with hash marks. But to be a congruent polygon, it has to be equal on every aspect. So it has to be the exact same size and shape. So let's give an example here. Maybe I'll do a triangle this time. I've got two triangles. Now to show that they are congruent, I have to know that all of their parts match up perfectly. So maybe this side is the same length as this one. Oops. And this side here is the same length as this one. And this side over here in blue is the same as this one. And that must mean that this corner here is the same as this corner if I were to measure it. Get some more colors. This corner over here is the same as this one. And this corner down here, same as this corner here. Now, if you notice, I did color code these, but the markings that are the same are the sides that are equal. They're not in the same position, like one is kind of turned or flipped kind of from the other. But as long as all the parts are the exact same, and they're both the same shape, they're both triangles, everything is matching up, they are congruent. All right, next one, perimeter. Perimeter is the distance around a figure, a polygon, a shape. Some people call it the length around it because we're looking for the total length or all the side lengths. So perimeter is the distance around a polygon. So let's make a rectangle or something that looks similar to a rectangle here. Whoops, not perfect, but use. So maybe this isn't quite a rectangle. Maybe this is 7 centimeters and this is 6 centimeters and this one is 12 centimeters and this one is 11 centimeters or something like that. If I was looking for the perimeter, which is usually abbreviated with a capital P, I would just add up all these numbers. I didn't make great numbers to add here, but 7, 12, 6, and 11. All right, let's do some math, Suchi. 6 and 7 make 13. 14, 15, 16. Carry the 1. 1, 2, 3. I got 36. I hope my math is right. If it's not, please correct me. But this would be the perimeter around the figure. Now, sometimes there are other measurements given. Maybe this one was, that's not mathematically totally correct, but let's say that was 13. We would not include that in the perimeter because we're only looking for what's on the outside of the figure. All right, next one, equilateral polygon. So it has the word equal in it. And then lateral means the edges or the sides. And then we have a polygon. So we want a closed figure that has all equal side lengths. So I'm just going to draw triangle's the easiest one here. And my figure was hand sketched, so it's not perfect, but if I want to show that they're all the same, I just need to put in marks or measurements where all the sides are the same. So equilateral polygon are polygons in which all sides are equal in length. Okay, now if we break it down like we did here, equal angular polygon, equiangular polygon. This is where the polygon's angles are all equal. So if I do a triangle, a triangle again, this time I want to emphasize the angles being all the same size. So this is polygons in which all angles are equal in measure. Now I use the word measure here because angles are not a length, they're a degree. So it basically means the same thing. They're the same size. They're equal in size or they are congruent. Okay, now a regular polygon smashes those two ideas together. So if I use that triangle idea again, I'm going to have all angles the same. And I'm also going to have all sides the same. So that means this figure is equiangular and equilateral. Okay, now that we've covered the vocab terms, we have some practice that we can do. So with this practice, part A says, which polygon is congruent to A, B, C, D, E? And if I look at A, B, C, D, E, that's this one right here. And this is a pentagon. So first we need to know that we're looking for a pentagon. All of our options are pentagons. And then we want to make sure that we're matching up the correct parts. So if I look at the first letter, corner A, that's got a double hash mark in it. So I'm looking for double hash marks, which this one has it, this one has it, this one has it. So far so good. The next letter is the letter B, and that goes over here with a single hash mark, and it goes across the side with a single hash mark. So if I was starting here, I want to go across this single hash mark to the next single hash mark in the corner. This one has single hash marks on either side, but none of the angles are marked, so that's no good. And this one has a single hash mark on both sides, and both of them have single hash marks on the sides. So I could go either direction in this case. All right, the next one, letter C. So that's going across the side that has a single mark, and it ends up at a 90-degree corner. So if I go here, across this side has double marks. Well, maybe I picked the wrong corner. Maybe I should go this way. Oh, this one has double marks as well. So that can't be right. Here I have a single mark and a 90-degree corner. Looking good so far. All right, the next one goes across a triple mark and then a 90-degree corner. Did I mess this up? Is this actually a double mark? Because here we don't have any triple marks. Uh-oh, so this one's no good. Maybe I had too fat of a pen. Look at that. It was a double mark on that side. Goodness, Such. Take your time in drawing your shapes. All right, so let's go back because this one's still viable. So let me recap. The N matched the A. M, oops, M matched the B. And then it was a double mark that went across to the 90-degree. That matched. And here's that triple mark that I saw before that this one was missing. So because this has 3 marks and this one has 3 marks, leading to a 90-degree corner, we're still good. And then finally, double mark over to single corner, double mark over to single corner. So here it looks like we do have a winner. Now I need to name this appropriately. So I can't just pick any corner to start with when I name this, it has to be the same order as the A, B, C, D, E. So it went A double mark, that was our letter N, B, which was our letter M, L was next, matched with the C, and across to Q, and up to P. So A, B, C, D, E is congruent with N, M, L, Q, P. All right, letter B, what is the perimeter? So here we have a parallelogram because the opposite sides are the same length. Perimeter, remember, we just add them all up. 25, 25. So 20 and 20 makes 40, 5 and 5 makes 10. So this perimeter is a length of 50. And they do have labels here. So I'm going to continue that label, 50 centimeters. Letter C, up at the top here, it says given the polygon, what kind of polygon is it? So first we have to classify it by counting 1, 2, 3, 4, 5, 6, 7 sides. 7 sides is a heptagon. And then the second part of that says, how would you label it or name it? So remember, we get to pick where we start. So whatever letter you want to start at, I'm going to pick G. And then you can go clockwise or counterclockwise. I'm going to go clockwise around this. So I'm starting with G, then O, B, E, A, R, S. Go Bears is our heptagon. All right, now it's asking angle A and angle what are consecutive angles? Consecutive means next to. So if I'm looking at angle A right here, I want to find an angle that is connecting to angle A that is next to it. So I have two options. I have angle R or I have angle E. So either angle R or angle E would be consecutive angles to angle A. All right, the last one, RS. Technically, that's a side, so we would usually have this segment bar above it. RS and blank are consecutive segments. So these would be segments that are next to each other or they are connected. So let's just clean this up a little bit here, and I'm going to choose the segment that they listed for us, which was RS. RS right there. So I need another side basically that is connected to RS. So again, I have two options, GS or AR. Now I can interchange these. I can say GS or SG. It doesn't matter which letter comes first. So either one, GS or AR. Wonderful. All right, here's our summary for this lesson. We will save that as a refresher for the next day.